Hi my friends, today we model this part, which is a support called by me hanging bracket. It was suggested to me by this drawing of Timoteo Carrera Soto. You can be interested what is this for, to be reverted with this base up. Well, this was the situation in the years 1900 and after, with this organization of using machine tools with belts, because there was a single steam engine placed at one end of the hall, which produced movement of a shaft placed on the ceiling, so that this is why it was placed in such a position. Of course, I used this drawing to make a modern one. That modern drawing is this one. There are some elements with interesting shape. For instance, this end, which comes from a sketch. Timoteo Carrera Soto, the author of the drawing, created this sketch, as you can see. What do we see here? We see that there are three arcs, one up and one to connect this up arc with this line, and he created this combination of lines by drawing a line from this point to this point, then a perpendicular to this plane, which contains the separation between the small arc and the large arc. Dimensions are here, and this point is very important because this is the place where this line goes. Yes? And if we consider the section, we see that these two lines are ends for cylindrical shape. We must consider the position of this point because we don't have any dimension to place these two lines at an angle. We don't have a dimension. We have to use this point. This is why I made this special sketch to detail the geometry of the place. Perpendicular is this line on this line. This line is perfectly defined between these 2 points with dimensions. Then you draw a perpendicular on it to obtain this point. Yes, this is the key of the drawing, because we'll use that point to draw the line L, this point being coincident with the line L. Okay, we start by creating half of this object. half about this plane and half about the other plane so that we create a quarter of the part. Then we apply mirror twice. Well, we have dimensions here to create that construction. I don't read them for you. There are dimensions also here, but we work with them and we see how to make this model step by step. I expect you to appreciate how much I worked on this drawing with so many details and dimensions. Let's start standard millimeters IPT. Start 2D sketch, XY. I recall the model browser and we start to draw lines. We start by drawing a line, a center line, from the center point down 195. I move this to be more visible and I disable the center line. Center line, I keep pressed the left button and I go to the right in order to create an arc. Then a small line, other lines, as you can see now. You see, this is now aligned with the 2 at the right. What means this? This means that they can be moved together, but we don't want this. So that I click here, I see 3 constraints and I select the one who is connected to the right line, this one. I delete it. Then the other one, also 3. This is to be deleted. Now we can move separately that ones. Be careful with this kind of problems because you can be wrong. Dimension, we start with the larger dimensions. This is 184, this is 380, 380, 5 millimeters here from this line, 5. This is smaller. The dimension is 370. 12 is this, and 26 is all. Good. Here we have a radius of 64 and we draw the inside sketch as you see here. This line to here is 36, exactly 36, and the bottom one is 145 from the center point. 145. We apply a fillet of 20 between these two lines and also here. Then I select construction to draw auxiliary lines. One is this horizontal, then a parallel to this. If I hover over this, I have parallel, you see now, and I go to this point, and then here dimensions. This point is placed here with 2, 1, 2. You see diameter here. It is not a diameter but symmetrical dimensions about this axis. And then 8 millimeters is this, and also here I copy the value from here because it is the same. Okay. Then an arc between these two lines with the center over the other one, and a distance of 8 here. Another construction, auxiliary construction, is a new line, construction line, from this point on the horizontal. You see now it is not parallel, but if I go here, it is parallel. Yes, we have this possibility to place parallel lines. Dimension, of course, 8, but from the other reason. You'll see what is that reason. Okay, we apply 110 this dimension, and also 245 from here, 245, 245, no, 254. Okay. And 120, 150 is this point to the axis, 150. only one dimension is the last, and that is this one, 240. Okay, we have something here very interesting, but I continue to create other lines because we'll use this drawing, but I don't know what is this here. Not 34 but 64. I said 64 and I placed 34. Now it's okay. I go to this sketch now to place it in advance, because I will use in the future. Okay, I draw a vertical line, center line. I disable this, I enable this with 65 length. Then normal lines, I disable this. I go to the right from this point, keeping pressed the left button and going to the right, not down, to the right. Then another arc here, a vertical, and close. This point is the center of this arc. Yes. The other dimension is 49. Now, what is the placement of these two arcs? As I said, I go to construction lines, I draw a line between these two ends, I draw another line between the connection point to the center point, I make them perpendicular, these two, but this was not placed very well, so that I make coincidence here. Now we have on this line the 2 points, which means that here is tangency. Yes, between these two is a tangent constraint. Okay, this is only for the future. We'll use it. All lines will be construction lines. Now we have 3 dimensions needed. What is the other one? Diameter. Which is 53. 53. Good. We align the button, this button with this button, and we know that this line is at a distance of 150 between these two center lines, of 150 divided by 2. Now we have that construction to use it later. Very interesting is that we have here a contour which can be extruded. If we go back to the drawing, we see that this horizontal volume is 9 millimeters thickness, and this one is also 9. So these faces 1, 2 are at the same thickness. We use half of it because I told you that I create a quarter, in fact, of this mid volume. Finish sketch. Extrude all this to us 9 divided by 2. Very interesting. We share this sketch to use it in the future. As you know, share sketch. Now I see here 150 and 75. Let's see again this shared sketch, which is the same with the other. What we change here is changed also here. Oh, I know what is here. I don't need this dimension, which is for this line. It was before 75. I eliminate it and I place this line to this point. As I said, coincident this point to this line, and you'll see that this will be moved. Yes? Now it's okay. Here is a difference, a distance, because they are not in the same position. Finish sketch. If you open this, you see the same. I hide this sketch and I take a look to this one. You see, 75, never 150, as I said. They are mirroring in a mirror. What is here is also here. If you change one of them, the change will be received by the other. Good. Now we go to the drawing and we can see something interesting. Let me show you here. You see, this face is at the same level with this face. As you can see now, the three ones are aligned. Dimensions are here. This is 46, this 46, and this one is also 46. You see, this face and this face are 46. Very good. We use the shared sketch to create some new sketch, one sketch in the same plane XY. F7, and we project in this new sketch, we project lines from the other sketch. These 3 lines and this one and this one, as well as no, this is not necessary. Then I hide the base for this drawing, the shared sketch, and I have here lines, but I don't see them. Alt Fi, colors, high contrast. Okay, you see that projected lines. I apply offset of this at 8 millimeters, as you know, and since I want to create that lines, I draw a new line over this one from here to this line. I make this projected line. Why? To apply extend here, and also extend the other one. I draw connections between these 2 lines, and these 2 arcs, and also this 2. Why? Because I want to create close contour. This is also normal line, and the other are all normal. Okay, finish sketch. I have a sketch there. I apply extrude to this area and this. What is the distance? 46 divided by 2. Not cut, but join. Not that direction, but the other one. Okay? Okay. I make again visible the shared sketch, base sketch. Let me place a name here. Yes? Basic sketch. To have a name. Now I make it visible, yes? visibility. Where is the visibility? Visibility. I can use Alt V. Let me apply. Alt V. Now we have here lines, and this one is very interesting for us. Why? Because I apply a plane perpendicular on this line in this point, then another plane at an arbitrary distance, say 10 millimeters is enough, as a sketch base. Double click. Now one click and sketch. What is this about? F7 is about to create a circle, because we have this sketch here. 9 is the thickness, and diameter of 16 is this long cylinder, this, or this. Yes, this is a cylinder here, and 10 millimeters is roughly from this face to inside. Everything will be covered with this cylinder later. What is the dimension? 16. Yes? Good. 16. I draw a circle with the center right here, so that I need to project this line as a point, because the plane is perpendicular to the line. Project this line, and we have here a point now. Circle is green, is good. Diameter of 16. This plane is the mid plane, not the side of this volume, and is placed in the XY plane. This here. I tell you about this plane, this face. Finish sketch. This is to be hidden, and we apply extrude to the only closed contour in this sketch, and we go to the face, to this face. Join? Yes, join. Okay. This is to be hidden as well. Now we use again this basic sketch to create that cylindrical volume which is here. I project that lines in a new sketch in this plane XY. F7, and we project some lines. Project one, lines and arcs. This arc, this line, and the upper arc. Then I hide the basic sketch, visibility, because I have that entities placed. I forgot this, but I can draw it manually, no problem. Okay, fully constrained sketch, of course. Finish sketch, revolve. Automatically, my friends. Okay. Next is this volume, which has dimensions here. As you can see, 9 millimeters is this thickness, which is already placed there, so that we draw only half of this contour with this radius of 5. This will be after placed here. 36, 9, 47 and radius 5. 47 is a double of what we need. We turn this model, we select this face and we apply sketch. The sketch is, as I said, starting from here to the right, horizontal, down, then keeping pressed here, we go to the left, to the end, and we close that contour. I repeat, this bottom or back face is the plane XY. Dimensions 9. Let me start with radius 5 here. 9 is this. And this one is 47 divided by 2. Finish sketch, extrude, not to the left but to the other direction with the join to a face, to this face and its extension. Yes, you can use this to next and it will be stopped here and here, but this is the same. Okay, here is also radius of 5. Don't forget this. Good. Now we take a look at something very, very interesting. The most difficult part of this modeling. You see, this is not a parallel orientation of these two faces. So we have to create from this flat face to this different section to up. Now we don't have this placed here and it starts on this face. it ends on this face. What are the dimensions? The dimensions are 70, or 70 divided by 2 for us, to this 46. You see here that end. We create some auxiliary entities to do this. Be careful and take a look at my procedure. I select plane, this edge and this point. Now I have a plane there. Good. Then I create a sketch in this plane. F7. This sketch uses a projection of this face, which appears here in the plane, of course. Why? Because I want to draw a line, a small line, not important how long is, but to be horizontal, like this one. And with a distance, that line is ending here, perpendicular on this face, so that the difference is between 92 to 7 divided by 2, always. Good. The distance between these two is parenthesis 90 minus 70, 92 minus 70 divided by 2. Which is 11. This is not all. I use F7 again because I want to project geometry, this face and this face. F7 again, and we have these two lines. This end must be on this line, any segment of it, and the other end also ends at this line. We make not visible this auxiliary entities, and we have this short line here. This plane is no more useful, so I make it not visible. Finish sketch. Good. We have that line. What next? Next is another projection on this plane, where I create a sketch. F5 to see the situation, and I project in this plane an arc, this arc, then offset of the arc to the inside at 4. Not 4, my friends, 8 divided by 2. We don't make calculus by heart because we have risks. finish sketch, and here we have that mid arc. We need to know the length of this arc, not angle but length. To do this we use inspect, measure, but measure has a shortcut M from Monaco, so I use this shortcut Monaco. Yes, when I say Monaco, I invoke measure. I select this arc and I have some dimensions. I'm interested in this one, the length, yes, of the arc. You'll see why. I copy this value and that's all with the measure. Remember, I have this copied length. Then I create a plane, mid-plane between this face and this face. You can use a specific mid-plane between two planes, but this is accepted as by default. In this plane we draw a line. To draw that line, we select the plane and we create a sketch. F5 to see from the same angle. You see this line. This can be projected on this plane and will obtain a point. F7 and project this line which is perpendicular on our sketch, and then we have a point here. From that point we draw a line. The line is this one. In the air. Finish sketch, hide the plane, and you see we have here a line. We are sure that this point is a perpendicular line from this point up is a line vertical, parallel with this. I go back with the plane, with the sketch. I double click here because I want to have that line placed here. Line from this point up, but this is not projected. I project this point and I draw that important line from here up to our line. Not perpendicular on it. Ctrl Z. vertical, not perpendicular on this line. This line is sloped. Line from this point vertical. Here it is vertical, which means horizontal, because this is axis Z. Good. Now I make on the same vertical, I place on the same vertical this endpoint with this endpoint, and I apply that dimension, my friends. This is the clue. Paste that dimension, the length of the arc. Yes, very interesting. Be sure. Finish sketch. That previous sketches, only this one is not necessary, but the other one is necessary. Yes, this one is necessary. Okay. To have an even more clear, I hide this sketch and I go back with this one. I select this face, I create a sketch, a new sketch, where I project the arc. Now I can hide that sketch, which is this one. Because I have this arc here. Then F7, I go with this line, I project it in the new plane. This is to be construction, but I draw a line between this end point to the midpoint of the projected line. Now I make this construction, finish sketch, and I extrude as a surface this contour. 1, 2 lines. Extrude. I select surface mode. Then this continuous line, not down but up, to something, to this line, to this face. Okay, now I can make visible this previous sketch. Not this one, but this one. I hide this and I open this. You imagine what I want to do? I want to project on this curved face this line, not only to this curve but also this one, but this is it contains that line. To do this we use what we did in other tutorial. I activate 3D sketch, project to surface, select the surface. This is the surface. I select both faces, then wrap to surface. What to wrap? This line. Apply. Now you see a line, a curved line on the surface. Very interesting. Then I hide the surface and the sketch, because I have what I wanted to have. Then, since this curved contour ends on this segment, I can apply finish sketch firstly. I can apply sweep. I want to sweep this entity as a surface mode on this curve. Now I have a surface here. Okay. On this surface I project this line because I want to section. I don't need that extension. Yes, triangle, that triangle, I don't need it. So that I apply again 3D sketch. I apply project to surface. This what is the face? Excuse me. This is the face where I want to project a curve, not wrap, but on a direction. This is the direction. Okay. Now you see here that line, not the end. I divide it into this face. Why? Because I apply extrude. Banally, ordinary, extrude. But I have to create this face. Excuse me. I select the face. I apply sketch, and I manually project the contour to be used as the base for the extrusion. Without this end. Finish sketch. Now is simple. Extrude, not as a surface but as a volume. What to extrude? To extrude this to this face. Okay. Now we see that there is a gap here. Yes, this is not good. So that I apply another strategy. I eliminate the extrusion, and I apply extrude of the same face to the same end, but as a new object. You see, this is a new object. I can apply color to see what is this object. Properties, not as part but red. Okay, now you see we have two volumes here and some surfaces, so on. Then I apply split by using this tool, and this object up I eliminate in the direction of the arrow. Okay, now there is no gap here. I hide the surface, visibility, and I combine this object with this object. Combine. Where is combine? Here is. I select the base body, which is this one. The color is from this, and then the tool bodies, this one. Okay, now we have a good solution for our problem. There is a 3D sketch which must be made not visible. Remember, only this is entire object. Everything, and also this, and also this. The other are half of this direction. Good. Next is to create this, or this feature with dimensions 60 on vertical, and the other are here. Good. Let's make this feature. This is the face. We draw a rectangle with 60 divided by 2 length, and we place F7 to see inside. We project only one line, this one, and we place this point up and the other down. Finish sketch, extrude to the part, to next, the other direction, join. Okay. And this is the result. Then here I want to apply half of 9, half of thickness, fillet. Okay. Here is 20. Plus 15. Okay. Now we can apply mirror, but we'll make this in steps. The first step of mirroring is from the first feature to this fillet, but without this feature we have to exclude, and we also exclude this revolution and this extrusion of a cylinder. What is the plane? XY. Okay. Now you see this is only parallel with this, not as this one, so that the next step is the combine. Here only work entities are, so that I select only the combine and the same plane. Okay. Now you see the result. Next mirror is only this extrusion. We have to apply steps here because features are interdependent. Okay. Now we have the full feature here, so that the last mirror is with these fillets about the same plane XY. Okay. We have here fillets and they are placed on both sides. Good. Next are fillets here of 10 and up also 10, plus five is here, up and the other. Okay. We can mirror the fillet 5 because 10 is all around, about the same plane. Okay. And then we apply fillets for the entire half of the part. 5 is here. 5 is also to the corners. them, plus 3 for this and this. Okay. Also here we apply 3 millimeters fillet. 3. Okay. Now we can apply mirror for everything. Everything means from combine to the end, plus also these features, not work entities. Mirror, this is the plane for mirroring. Okay, and we have the volume in a good shape. You see, everything is okay now. Now we concentrate on this revolution feature, which has also a hole. Dimensions are mostly here. As you can see, diameter of 30, diameter of 46, here is 36, and distance is 5, 17, 25. This dimension is taken from this, yes, which is 8. Yes, my friends, 8. The whole diameter of 17, diameter of 32, and 17 from the bottom. We remember that we observe that all dimension is 55. Good. We use this data to create a sketch in this plane. F7, and I draw a contour, a line of 55 as center line. Then dimensions, lines for the beginning, and then dimensions, and close. Dimensions, as I said, 30, 46, this is 36, and this is 54. 5 millimeters is this line, 8 is this, 17 the next, and we apply now fillets because there are 4 of them, all of them of 5 millimeters. 5. One, 2, 3, 4. Two dimensions. One of them is coincidence between the center point and the axis. If we take a look again to the drawing, we see that this line contains the superior line of this. Yes, this is at 145, but we use a projection. We project this line and we apply coincident to these two. Now I make this construction line because it is important for revolution. We apply a revolution, join, okay, 30, 360, okay. You see? Very nice. The internal hole is to be made as a revolution. We draw again a line, center line from this midpoint to this end, then normal line, 1, 2, 3, and a connection here. I mentioned dimensions. This is 17. The other is 32. And this distance is 55 minus 17. Finish sketch, revolve, cut, axis, select axis, and I suppose it's okay. It is. Then we have to apply 2 holes, metric 32, 43 the depth, 40 the fillet, the thread. One is here, another is here in the centers of the cylindrical features. We turn back. The body, we apply projection, and now we apply hole on this point and this point, but not through the part. Look here, threaded or tapped metric from ISO 32. The pitch, the normal pitch is 2 millimeters, and on a distance of 43 with the thread of 40 for both. Okay, there are some planes here from the moment when we made that multiple mirrors. We don't need to see inside to see such such elements there. The thread is here. The last thing to do is with these two holes. Diameter of 25, distance of 318. This plane, sketch, line, 318 on vertical, the midpoint over the center point, or projection of center point, but it is right center point. Finish sketch, hole, 1, 2, not threaded, through the part, 25. Yes, 25. Okay. Now this is the part. Final. Let's see what about the volume. Our goal always. High properties, physical, update, copy, close, double click, and I changed this because there were many attempts for this part, which is very in a very long tutorial. Excuse me, my friends, but this is when you have such a number of features and problems. Now we can apply a material for the part, which is still cast and not semi-polished, but also still cast. We apply shaded to see that nice object, and we also change the constitution of this object by changing also when you open again this part to have the same presentation. That's all for today. Thanks for watching. Bye bye.